All right, so here are some different things that you can try to remember, or some steps that you can follow whenever you are using implicit differentiation. So anytime we've got y's running around, like a y squared or cubed or a square root or something like that, you're going to use implicit differentiation. Okay, if we have something that just says y equals, then we can just use our normal straight up derivative rules. Okay. But one of the things that we're going to want to do is differentiate both sides of the equation with respect to x. So if you have just a y, if you have just y over here, then when you take derivative with respect to x, it becomes dy dx. Okay, so we already do that. But if you have y squared, we've got to multiply that derivative now with dy dx. Okay, collect all the terms with dy dx on one side of the equation, either on the left or on the right, but get all of those guys together. Okay, then factor out dy dx and then solve for dy dx. So how might that look for us? Well, here we've got a question. Let me move him up just a little bit here. So we've got this question. Find the slope of a circle x squared plus y squared equals 25 at the point 3, negative 4. If we're going to find the slope of the tangent line of the circle, find the slope of the tangent line, then I've got to take derivative. And how do I do that? Well, I'm going to take derivative of x squared. That's going to be 2x. I'm going to take derivative of y squared. So that's going to be 2y. And then derivative of y, dy dx. Okay? And then on the other side of the equation, I'm going to take the derivative of 25, which is 0. Okay, but you've got to remember this. It's really easy to forget that that zero's over there. Okay, now that's the first part. So the second part then is to collect all the terms with dy dx on one side. Well, we've got it over here. There's only one term. It's already on the left. Okay, do we need to factor out? No, but what can we do? We can move 2x from left to right. And so what that's going to give me is, whoops, that's the wrong color, green. What that's going to give me is 2y dy dx equals negative 2x. Okay? And then how do I get dy dx all by itself? I divide both sides by the 2y. And when I divide both sides by 2y, what happens? These guys cancel out. So dy dx is equal to negative 2x over 2y. All right. Now find the slope. Find the slope of the tangent line at that point. Well, dy dx is my slope. And so if I'm going to find the slope of the tangent line at that point, I'm going to simply take the point that I've been given, this x and y coordinate right here. Here's my x value. Here's my y value, and I plug them into my derivative for x and y. So this is going to end up being then negative 2 times 3 over 2 times negative 4. And what is that going to be? That's going to be 3/4. So the slope of my tangent line at the point 3, negative 4 is 3/4. And that's how implicit differentiation works. And oh, by the way, can we write the equation of the slope of this tangent line? You bet. We've already got a point. We just discovered that our slope is 3/4. So we could just go, hey, y plus 4 equals 3/4 times x minus 3. And there you go. That's all there is to it. Implicit differentiation, some steps to follow on a problem that's a little bit complicated, but not too bad.